wake up exercise. Here it is. Try to integrate this 1 plus dx on x. So you can use your u substitution however you like. Either go for the antiderivative, either use u substitution to go for the antiderivative, or use u substitution directly to evaluate the definite integral.
The bottom term is squared, right?
Yeah, so 1 plus g to the x quantity squared. Okay, turn to somebody next to you and say what you did or are doing. Okay, how would anybody like to say how they did it? How he or she did it? What do you take as your u? Anybody?
1 plus e to the x.
Okay, 1 plus e to the x. So let u be 1 plus e to the x, then your du dx is e to the x, right? And so I don't know how you guys what do you prefer? Do you prefer to go to solve for the antiderivative states and switch back to x, or do you? Well, who cares? Doesn't matter. So we got du over u squared, right? 1 over u squared du, and between what and what? Between what and what? Well, when x is 0, u is what?
2.
U is 2. Right? When x is 1, then u is 1 plus e. Right? So you can go like that and say, okay, so this is going to be u to the negative 1 divided by negative 1 between 2 and 1 plus e. Right? And that's going to be negative 1 over 1 plus e minus 1 over 2. Right? Minus 1 over 2. The end. What is it? Shay? Yeah.
So I got the 1 over u squared, but I did not get negative 1 over 2.
You got to here.
So if you pop up that e to the 2 up to the top, so e to the -2, which makes it easier to work with. When you take down or when you try and make it into a sort of backwards
Antiderivative.
antiderivative, then you have the e to the -3 on top, and then when you take down that -3, in order to get it to be the 1/e, so
Well, that's fine.
Right. So here we have this u to the -2, right? So it's going to be u to the -1 over -1. That's the same. -1 over -1 over u.
What's a -1 different from -1 over?
Because you've got u to the -1 here. You've got u. What does this change? U to?
Never mind.
Do you understand it, or you good? Okay, good. Okay. Anybody else? Okay. So again, if you don't want, suppose you don't like to change the range of integration. Yes.
I actually had the same question as Sharon. I just didn't actually read what was on the board.
Okay. Did I
We
make a
got
mistake?
1 over u cubed as the antiderivative. What did we do wrong? Or as the, so you know how you've got -1 over u? We got -1 over u cubed.
Well, this is u to the -2, right?
Huh?
So it's going to be, the antiderivative is going to be u to the
Oh, never mind.
-2
That
plus
went the
1,
wrong way.
right? -2 plus 1, that's -1. Okay. Again, if you don't like to, so this was one way to do it. And then if you don't like to change the range of integration, suppose you don't like to change the range of integration, well, you could simply go for the, use the u substitution to figure out that the antiderivative looks like this. That's to say, -1 over 1 plus e to the x, right, plus c. You could use substitution to figure out the antiderivative, and then use that just use that antiderivative plus the fundamental theorem of calculus, right? So here you evaluate the difference of the antiderivative at the endpoints, and you would get, right, -1 over 1 plus e minus -1 over 1 plus e to the 0, right? That's -1 over 1 plus e plus 1 over 2. So you get the same thing, okay? So, in case for some reason you don't like to change the range of integration. But as you see, being able to change the range of integration shortens your work slightly. Okay, because you don't have to switch back, right? At this point, you don't have to switch back to the x's and then go back to the x's. But you did have to do the work to figure out the new range, so maybe it all balances out. It should be basically the same amount of work. Okay. Okay. And I don't want to give you the impression that it's okay just to understand one way. Try to understand both ways, because once you get to calculus 3, for example, it won't be. It'll be important to understand that you do have to change the range of integration, and the change of the domain of integration will become a lot more tricky at that point. Okay, so once you introduce more variables. Okay. Okay. Do people want to see another example, or shall we go on to the last technique? It's probably better to go on to the last technique. Okay, so last technique. This is from section 6.1. It's called integration by parts. So I'm skipping at least 1 or 2 sections, but this is more important. This is by far more important. So like I said the last time, a lot of the techniques of integration are simply counterparts of rules of differentiation. The U substitution is really the counterpart of the chain rule. This thing called integration by parts is the counterpart of the product rule. Of the product rule. Okay, so let's remember the product rule. So the product rule, of course, says that if you take a derivative of one function times another function, then you're going to get one function times the derivative of the second plus the derivative of the first guy times the second function. Right? That's a product rule. You know it. Right? So now, just like last time, we're going to rewrite this in anti-derivative language. Okay, so what is that saying? The derivative of this thing is that. In other words, this is the antiderivative of that, right? So uv plus c is the antiderivative of this. Everyone all right with that? Right? We just wrote the same, again, we write the same thing twice. Okay?
Is there a reason you're using U X and D X?
That's sort of just tradition. People, when they're writing, when people write about the product rule, one typically uses U and V as your symbols. Yeah. You could use F and G. If you like, just replace the U's by F's and the V's by G. Whatever you prefer. You can name your functions whatever you like. Okay. Okay. So let me rephrase this a little bit. So what does this say? This says that if I am looking for the antiderivative of this, it's the same thing as, let me write it this way, negative the antiderivative of this plus, let's see. Okay. Right. The antiderivative of u against v prime is negative the antiderivative of v against u prime plus u times v plus a constant. Okay. So what this is saying is that, in some sense, if you have two functions and one is a derivative, you can pass the derivative over to the other guy. Right? The antiderivative of a function against a derivative of a function equals negative the antiderivative of the derivative of the first guy times the second guy. You can pass the derivative over to the other guy, but at a cost. And the cost is that you have to introduce this negative sign, and also there's this thing here. Okay. And so this is abbreviated. This is usually abbreviated u dv equals negative v du plus uv. It's don't worry. Okay, so let me show you an example. Let me show you an example first. Let me show you an example of how this works. Somebody gives you this thing. Okay. find the antiderivative of the natural log of x. Okay. Does anyone know immediately what the antiderivative of the natural log of x is? Maybe not. Probably not. Okay. So, so what you do, here's what you do. You say, well, I'm going to think of this thing as the natural log of x times 1 dx. Okay, I'm gonna notice that there's a 1 in there. I'm going to think of this thing as my u, and I'm going to think of this thing as my v prime. Okay, so my u, I'm going to take my u as natural log of x, and I think v prime is going to be 1. Okay. Right, and what we've just said is that the antiderivative of u v prime equals negative the antiderivative of u prime. Well, what's u prime? 1 over x, right? For v, I'm just going to take x, right? I can take my v, the x. It's x plus c, but it won't matter. The c will be contained. Okay. We get v u prime v plus uv plus a constant. Okay, so I get negative the integral of 1, right? Negative the integral of 1 plus x ln x plus c. That's to say negative x plus x ln x plus c. Okay, now let's check it. If we differentiate that thing, right, negative x plus x ln x, we get negative 1 plus the first guy times the derivative of the second plus the derivative of the first times the second. Right, and you see that you get negative 1 plus 1, that's 0, plus the natural log. So we get the natural log. Okay. So we are able to use the integration by parts to figure out the antiderivative of the natural log. Okay. So again, remember it, right? The antiderivative of uv prime equals negative the antiderivative of u prime v, right? U prime v plus uv plus constant. Okay. Okay. When I was in high school, we read it like this. Right? We'd say, well, I'm going to take my u to be natural log of x. I'm going to take my dv. I'm going to take my dv to be dx, and then so my du is going to be 1 over x dx, and then my v is x. Right, so you make this little box. I don't know if this is useful to you, but and then you say, okay, so the integral of u, the integral of u dv is equal to the integral of v du minus the integral of v du plus uv. Right, so you'd say, okay, well, this is going to be minus the integral of v du plus uv. Right. So whatever. I don't know if this is this notation simpler or I don't know if this helps you or not. But this is maybe a cleaner, slightly cleaner notation. Yeah, Sharon.
So u from 1 dx plus x ln of x plus c to negative x plus x ln x and c.
Mhm.
Why? It's like, how did the,
From here to here? Or from here
well,
to here?
no, from the.
From here to here?
Down.
Here to here?
From that one to the,
To here.
yes,
Yeah. Well, what's the antiderivative of 1x?
yes.
So I got negative x plus x ln x plus c.
So why?
Oh, because that's just part of that and from the definitions.
Oh, never mind.
Okay.
Okay, is that, okay.
Right. So I want.
So you're not doing the antiderivative of both?
I'm not doing the end. So when I have this dx here, basically tells me the end of the indefinite integral. So the dx means I'm not gonna. This integral, this anti-derivative means you're taking the antiderivative of this thing in the middle here.
Okay.
You're not taking if the dx were over here, then I'd have to take the antiderivative of that. But the dx is like you can sort of think of it as like the period for this sentence. Okay. Okay, let me do another one. So, again, antiderivative of x ln x dx. Okay. So, so maybe I'll do it like this. There are actually a couple ways to do it. Here's one. You could say, well, I'm going to take my u to be natural log of x again. Right? I'll take my dv to be x dx. Right? In other words, I'm taking my v prime to be x. Right? dv dx is x. Right? Again, my du is going to be 1 over x dx. My v is now going to be x squared over 2. Right, so again, the integral of u dv is going to be u v minus the integral of v du. Right, so I get this is going to be u times v. Right, u times v minus the antiderivative of v du. Right, x squared over 2 over x dx. Right? So that is x squared over 2 natural log of x minus the antiderivative, right? Minus a half the antiderivative of x, right? The antiderivative of x is of course x squared over 2. So I'm going to get x squared over 4 plus c. Okay. Okay. Everybody see how this goes? Any questions on either example? Any questions on either example? No, you're good? Okay. So let's see, maybe I'll have you do one. Yeah. So okay, so one comment, okay, about the choice of u and v, right? You want to choose your u to be something that you can differentiate, right? Because your u v prime equals negative, oops, equals uv minus u prime v. Right? You want to choose your u to be something that you know how to differentiate. You want to choose your v to be something that you know how to find the antiderivative of. Right? So here I've chosen my v. I've chosen my v to be x. Right? My v is x. Why did I do that? Because I know how to anti-differentiate x. Right? Of course, now we actually know how to anti-differentiate natural log of x. So you could have chosen that. You could have chosen that natural log of x as your v. Okay. But basically, roughly speaking, you want to choose your u to be something you know how to differentiate, and you want to choose your v to be something that you know how to anti-differentiate. Okay, so that you can actually apply the formula. Because in other words, you have to do that because you need to do that to apply the formula. Okay. So okay, with that in mind, please try the following example. Here it is. Something you would never have dared to do before today. Right? It looks awful, but it will not be so bad. Oh, actually, this one's a little tricky. It's just a little tricky. There's a tiny bit of cleverness in it. Let me put up another one that I'm not sure if it'll be any better. So here it is. The antiderivative of the inverse sine function. Will this be any better? Do you remember how to differentiate the inverse sine function? Okay, so remember the derivative of arc sine is 1 over the square root of 1 minus x squared. Okay, with that, now your choices are clear. You're going to choose. Do it. Okay, talk to somebody next to you for a few seconds.
Inverse sine. Yeah. I just don't know. I'm leaving it. I don't know. I'm sorry. I know. I dropped negative. So okay.
Okay, so what do you choose? What's going to be your u? Of course, u is going to be this, right? Your v is going to be what? 1, right? 1. Yeah, your v is 1, right? And then so your du is 1 over your squared dx, and v is x. So you get what I write here, uv minus the integral of v du. Okay. And then what do you do with this thing? U substitution, right? So you say, well, let my u be 1 minus x squared. Now, this is a different u from before. Okay, so this u is not the same as that, of course. Right? Let my u be this, right? Then du is negative 2x dx, right? And so this thing I'd like to have a negative 2x dx, but I don't, so I throw in the negative 2, and I divide by negative 2 also. Right? So this thing is this, right? I rewrite, this is going to be 1/2. Now I'm going to describe it in terms of u. This is du 1 over u to the u to the negative 1/2 du. Right? Here's the du. Here's the u to the negative 1/2. Right? And so this is going to be u to the 1/2 divided by 1/2. Well, I had a 1/2, so they just cancel. Right? So u to the 1/2 plus c. In other words, I get u to the 1/2 plus c. Yeah, sure.
What happened to the sign?
It's still there. Right now we're working on what this thing is. Okay, we're just looking at that. Okay. So putting this back together, we get that this we just figured out what this thing is. So this thing is going to be equal to x sine inverse x plus the square root of 1 minus x squared plus c. And that's the antiderivative of the arc sine. Okay. Again, things which were basically impossible are now well within reach using the product rule, right? Using the product rule. So I hope that seems sort of cool. Of the various techniques, I think this one is one of the cooler ones, maybe the coolest. Okay, Okay. Notice that all we've been talking about for integration by parts is the antiderivative, but if this were a definite integral, right? If this were a definite integral between a and b, then you would just take the difference of this thing between a and b, right? You found the antiderivative, you just take the difference between a and b. Okay, so there's nothing particularly exciting about that. Yeah. Yeah.
So, in the beginning, why are you doing x sine versus x minus the integrals?
Remember, the integral of u dv actually equals uv minus the integral of v du.
Oh, I guess I wrote that down.
Right? The reason, and just keep in mind what's going on. If I bring this thing to the other side, I have that u dv plus v du equals ue. That's to say that that the derivative of this is u v prime plus v prime v u prime, right? The product law, right? Okay. 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 So here's something strange that might happen. What are you going to choose? In this case, what will you choose as your u and your v? Why not? Let's choose u to be x and your dv to be cosine x dx. Okay? It doesn't matter. What I'm hoping will happen either way you choose. You could have chosen the opposite way, but it'll happen anyway. U then is going to be u dx dx, and v then is sine x. Right? So what do I get here? What do I get? Somebody just read it off to me. U times v, right? U times v minus the integral of v du. Whoops. Right? Okay, so you end up with something like this, right? Now, let's apply integration by parts again. I'm going to take my u to be u dx, my dv to be sine x dx. du is again u dx dx. V is going to be negative cosine x. Right? So, what do I get? Right? What do I get? I get e to the x sine x minus what? Negative cosine x dx minus the integral of v du, right? So that's going to be e to the x cosine x dx, and I have a negative sign on it. Right? So what do you do at this point? Hopefully you do not say, let's do integration by parts, because if you did, right, that would be the end of your life. Right? Because you would just go back, and then you keep on this e to the cosine x, e to the x cosine x would keep on popping up, right? Okay. So, but instead of doing that, you do something clever. Okay? You say you make an observation, a clever observation, or at least a life-saving observation. Okay. So right now we have this. You make the observation that I can just move that one to this side. Right? I've got positive one here, I've got negative one here. I'm just going to bring that one to the other side and then divide by 2. Right? I'll just add the integral that I don't know. I don't know what it is, but I have 2 of them. right? Two of them equals that, and so one of them equals half of that. Oops. So sometimes this sort of thing happens. It's not. This actually is not that contrived. So this sort of phenomenon often occurs. You end up with something. You're trying to figure out something, and you end up with a multiple of it on the other side. That's not one. You move it over and then divide. That's handy. Okay. Any questions? Any questions? Okay, the last example. Okay. X is e to the x cubed dx. Okay. Right, so you want to choose your u and you want to choose your dv. And the hint is that you want to choose your dv to be as big as possible. So be greedy in choosing your v. Okay, that is dv should be something that you can integrate. Look for the biggest thing that you can integrate. Be greedy. So be greedy in choice of dv. So take a minute and see if you can get it. I'll hand back more homework. Okay, so what are you gonna choose? What's your DB? What's your DB? Maya.
X squared e to the x cubed.
X squared e to the x cubed. Great. Right. That is probably the greediest thing, the biggest thing you can do. Right. Right, because you know how to get the antiderivative of this, right? So then your u is going to be x cubed, right? Du is going to be 3x squared dx, right? And your v is what? What's your v? What's your v? If dv is this, what's the antiderivative? Maya, go ahead.
E to the x cubed over 3.
X cubed, right? Because when you differentiate that, you're going to get e to the x cubed times 3x squared, right? E to the x cubed, right? E prime is e to the x cubed, 3x squared by the chain rule. Okay, and so what's this going to be? It's going to be v uv, right, minus the integral of v du, right? So we get x cubed minus x squared yes, so we just saw what that is. That's going to be negative 1/3 e to the x cubed. Any questions? Right? We get uv minus v du. These things cancel off, right? We get negative the antiderivative of x squared e to the x cubed. But we just saw the antiderivative of x squared e to the x cubed, right? That's 1/3 e to the x cubed. Let's see. Okay, good. So that's the end of the course. Goodbye. Until the final. Yeah. Yeah. So congratulations, you made it to the end. You stuck it through to the end. Good. Keep on going. Keep on going. I hear that people feel like if you don't get 100%, if you're not getting an A in the class, you don't feel like going on. That's nonsense. Just keep on going. If